Hey there, everybody. Welcome back. This will be our third section in chapter 3. 3.3 is on polynomials. We're introducing polynomials. So a polynomial is a combination of terms of the form ax to the n, where n is an integer greater than or equal to 0. Just whole the natural numbers. 0, 1, 2, 3, 4, all the way up. They have real coefficients, positive integer exponents, and no division with variables. No exponents on, or no variables on bottom. So like x to the 5th power minus 3ac squared plus 7x squared y cubed z to the 7th minus or plus 10 I don't know, w is a polynomial. It's a weird polynomial, but it's a polynomial. In general, in this class, we're not going to do a lot with those. We're only going to have polynomials with single letters. But if you have questions about it, there's a couple terms we need to talk about. The degree of a term. Is the sum of the exponents on the variables. So if I look at the degree on this one right here, this is just 5. A has got a 1 on it. C has got a 1 on it. B has got 2. 1 plus 1 plus 2 is 4. And we don't count that. We don't look at the coefficients. We don't care if they've got exponents or not. Here we've got a 2 plus a 3 plus a 7 is 12. And the W is just a 1. So those are the degrees of those terms. All right. Generally, we write terms in descending order based on degree. You won't have to do something like that. So let's just give an example where you might need to do something. We want to write this where the exponents are in descending order. So it might help to underline them as you grab them. The 5th power is the biggest one. Then I have 7x to the 4th. x cubed, 5x squared. That's to the first power, and this is like x to the 0 power. So minus x plus 2. That's written in descending order. When it's written in descending order, this term is called the leading term. And the leading coefficient, 6, the number in front of it. They describe polynomials by the degree of a polynomial equals the degree of the highest degree of the terms. So this right here is called a 5th degree polynomial. Okay. So what can we do with these? We can add and subtract polynomials. That's what the rest of what we're going to do in this section. Let's just do some examples and you'll see how it works. And you know what? We'll do that same one with subtraction. Then we'll do a couple more. Here we add terms based on their exponents. We combine like terms. This doesn't actually need to be written with parentheses. I'm just writing polynomial. And this is the second polynomial. But when we add them, we don't even need the parentheses. So we're going to combine 5x squared with negative 5x squared, and we get 0x squared, which we don't even need to write. Anything times 0 is 0. Then we take a look at the 3x and the negative 3x. That adds up to 0x, and we don't need that one either. Finally, we have 1 plus 7 is 8. We add those together, we get 8. When you have subtraction of polynomials, you need to pay attention, distribute the minus sign first. I'm going to distribute minus sign to each one. It changes the sign of what's inside. Now when I combine like terms, I've got 10x squared, 6x minus 6. All right. Why don't you guys give it a try? We're going to do 6x squared y minus 7xz. And we'll add to that 7xy squared plus 6xz. Go ahead and pause the video, work that out. All right, so if I combine like terms, these are not alike, they're different. This has got x squared, this has got x, this is y, this has got y squared. They're different. There's no combining those. We have to leave them separate. These both have xz to the first power. So we can combine those. -7 plus 6 is -1. All right. And give your hand at a -1. All right. I am going to rewrite these as negative, and I'm actually going to line them up underneath the terms that have the same exponent. So -6 is +6x squared. Negative times +4x is -4x. And negative times -3 is +3. And now I can just add these vertically. I got x cubed minus x squared plus x. And that's a 0. So that's it. That's your introduction to polynomials. Make sure you write them in descending order. Okay. Peace.